Right, Bismillahirrahmanirrahim. Welcome to the third lecture on probability and statistics. Right, before the Eid break, किसी को याद है हमने क्या discuss किया? Everybody remembers? So as I mentioned, we have the recordings. So please view them. And yes, you were saying.
Independent events पढ़े थे.
Independence further, right? So we covered a lot of things in the first two lectures, right? Yeah, they were relatively longer lectures, so we got to cover a lot of material. We have been talking about probability being lack of knowledge, right? So when there is uncertainty in the things you are dealing with, we have probability showing up there. So we had discussed also how we can work with probability to still be able to design something. For example, I had mentioned, so I'm going to go very quickly through what we did before, but I won't go into the details. We developed all these things in great detail. I'll just do a very quick review of what we did. So we said you know your height, but you don't know the height of the next student coming into the room. There is uncertainty in there. Yes? But within that uncertainty, we still have information about human heights. So we could use that statistics and our understanding of probabilistic formulae to design or plan for different eventualities. For example, the size of this door, right? You can make decisions, not just design. Your mobile phone takes your fingerprint or your facial recognition. Even though there are variations, it can still make a decision, 99.99% probability that it's you, right? And then it lets you enter or unlock the mobile. So design, decision making, with whatever information we have, we can still try to do the best. So the final thing I was discussing before the Eid break were 4 important probabilities, if you remember. So we talked about assigning probabilities with certain conditions. Then we talked about the assigned probabilities making sense. Those were the axioms. Again, all of that is in the recordings. Please go through those. If you feel that you don't recall what I'm talking about, just go through the video lectures there. So the final thing we were talking about were 3 or 4 probabilities. This is small enough, I suppose. Yeah. So there was the joint probability, conditional, posterior, and total. Okay. So I had finished up to here. My plan was to complete all 4, but I had done up to posterior. So today we will continue from total. But before I go there, I really want to do a quick recap of these. It's still quite big, so let's see if we can get that. Okay. So I'll go with an example and quickly revise these without the development that we did before. Okay, just a summary. Let's say I give you a piece of paper and I say, before you open it, I tell you that I have written a number from 1 to 6 on it, an integer. 1, 2, 3, 4, 5, or 6. Yes? So if I say that I have written a number 1, 2, 3, 4, 5, 6 on it, before opening, yes, you can already tell, okay, the possibilities are what? 1, 2, 3, 4, 5, 6. Yes? What's the probability? This thing we call, what did we call it? Sample space. Yes? The universe of possibilities in your current experiment where you're working. Yeah? Okay. So, and let's say this is one event that I wrote a 1. Yeah? Now assuming that they are all equally likely that I randomly pick one of these when I write I'm not a person who always writes 2 or 3 or an even number. Okay, so if I don't have those kinds of dispositions, we can assume that each is equally likely. In that case, we said the probability of A, what was it? Probability of A, it was the count of A, the size of A divided by the size of the sample space, right? Which you already know, the probability of A is 1 by 6. Okay, so we did that in detail. Where does joint probability come in? Okay, let's say I want to see this. What's the probability that, let's say this is event B. When B says that I wrote 1, 3 or 4. Okay, so what's the probability that I wrote A, that event A and B occur at the same time? Both of them are satisfied. Okay, so what is the probability of that? You can guess from here. Probability of A and B. So A is satisfied and B is satisfied. B says I wrote 1, 3 or 4. A says I wrote 1. So what's the probability that both these conditions are satisfied? Well, it's 1 by 3. Is it 1 by 3 or 1 by 6? Because the two are only satisfied together if I have written 1, right? If I have written 1, A is satisfied. If I have written 1, B is also satisfied. It says I wrote 1, 3 or 4. Yes? So for them to be satisfied together, I need to find the common element. Yes? What is the common element? There is just 1 here, and out of the total 6 possibilities, it is still 1 by 6. But joint probability we discussed in detail last time. I'm just mentioning it here. What if I had another event? Let's say I have an event, this C, which says that I wrote an even number. What's the probability of A and C? What's the probability that I wrote 1
0
and I wrote an even number? 0, right? So what did we call such events? That's what I want you to recall now. Yeah? Mutually exclusive. Yes? Equally likely were that have equal probability of occurring. Mutually exclusive were that cannot occur at the same time. Yes? So A and B, are they mutually exclusive? No. They can occur at the same time if I had written 1. However, A and C in this case are mutually exclusive. For mutually exclusive events, the joint probability is what? Zero. Okay? So the events occurring at the same time, the probability of that happening becomes 0. And this we call probability A and B. Yeah? There was another one before this, which was probability A or B. किसी को याद है? A or B. In this situation, what does that mean and how much is it? Quick class. Or was shown in sets through union. Yes? So I'm saying, what's the probability that I wrote a 1 or I wrote 1, 3 or 4? Right? A or B. We could do A or C also, it's fine. So what's the probability of that?
1 by 2 is 3.
So we got 2 by 3 and 1 by 2.
1 by 2.
Okay, let's check. So this can be satisfied. How can it be satisfied? If I write 1, 3 or 4. Yes? That way A or B, not and. They don't have to be satisfied both. So one of them has to be satisfied. There are only 3 elements here in A union B. Agreed? Yes? Only 3 parts here because 1 is common. Yeah? So you only have 3, so it's 3 by 6, which is 1 by 2. Yeah? So But what I want to show you here is, if you recall, we discussed there was a general way of writing this thing. There is probability A, probability that I wrote 1, plus probability B that I wrote 1, 3 or 4, which is event B, minus what? Yes. Why was that? It's just a quick revision actually. We did that in detail. Why was that? Because you counted 1, if you write it like this, you would have counted 1, this thing, twice. Yes? Whatever is common between them, you would have counted it twice, so your calculation would be wrong. So you have to remove it once. Yes? Now for mutually exclusive events, what happens to this formula? Does it become simpler? Let's say I was talking about A union C. We already established that A and C are mutually exclusive.
You
Yes?
can directly add them.
Yeah. So the third term disappears.
Yeah.
Why is that? Because for mutually exclusive events, we already know that the third term is going to lead to a 0.
There is no common term.
There is no common term. So they are directly additive like this. You could put that and then find that it's 0, but if you already know it, that they are mutually exclusive, just skip it. Yeah? And this helps a lot. Trigonometric formulas, when we are solving these problems, we use sine square theorem plus cos square theorem. If somebody doesn't know that this equals 1, they will be just calculating it all the time, right? But you know it, you can quickly replace it with a 1 and make your entire calculation much simpler, right? Jahan bhi wo factor aana hai, this will be replaced by a 1. Similarly here, once you know something, put that information in there and make your calculations simpler. Abhi to here it seems yeah, trivial, okay, if you put a 0, but imagine working with bigger probabilities, पूरे पूरे subject पे जब होगी तो even these small changes, small simplifications would help a lot, right? Reach a very good interpretable conclusion. Yeah. तो फाइनल फॉर्मूला अगर सिंपल हो ना तो फिर उसकी इंटरप्रिटेशन आसान. अगर आप 4 सफ़े का फाइनल रिजल्ट निकालेंगे उसकी इंटरप्रिटेशन कौन करेगा? So you have to bring it to its simplest form. याद आ रहा है 8वीं 9वीं में कहते थे simplify, इसीलिए कहते हैं शौक नहीं आता. They want you to learn these things. Yeah. Okay. So again, part of the revision, mutually exclusive, if they are or not, this is the general formula. Makes sense. Joint probability is here. किसी को याद है conditional क्या मामला था? What was conditional probability? Can somebody help with that? So sometimes knowledge of one event can help us with assigning probability to another event. Okay, so in probability A and B, in this case, we are saying A is uncertain, B is uncertain. What's the probability that they both occur or both are satisfied? We found that 1 by 6. Now, in situations, let's say I give you this same example. You have the piece of paper. Before you open it, as I said, what's the probability A of A before you open it is 1 by 6. You have already calculated. What if I tell you that I wrote an odd number? Okay, so before you open it, I tell you that I wrote an odd number. Now what's the probability of A? 1 by 3. Why is that? What happened? So firstly, let's rewrite what we did last time. Let's call that event C. Oh, get used to that.
Undo.
Oh, good. Right, so let's call that event D that I wrote an odd number. Yeah, so now as your friend said, I'm talking about what is the probability that I wrote 1, that is A happened, given that B has happened. Now this is different from joint probability. In joint probability, both are open. I don't know whether one happened or not. Here, we either assume or we are given Whatever, when we work with here, we want to assume that D is a done deal. It has happened. Okay? You could be playing what if. What if it has happened? That's also fine. As long as you know what's your assumption is. Your assumption is that D has happened. Now, what's the probability? That it's 1 by 3 now, right? Why is that? Because now your sample space, the universe of possibilities, has shrunk considerably, hasn't it? It has shrunk to half of its original size. So it's left from 1 by 6 to, the probability increases to 1 by 3. And we have seen a formula for that in terms of the joint probability, which is probability A and B divided by probability of, sorry, this is G, so probability of A and D divided by probability of B. And if you calculate it like this, you will again come up with 1 by 3 as you did before. Yeah? So the condition is that PD should not be 0. Mathematically, division by 0 is not allowed. Last time I said I will let you think logically why that should not be allowed. किसी ने सोचा उस पे? So PD cannot be 0. Right?
आंसर भी निकाल सकते हो, इंफिनिट हो जाएगा.
वो तो mathematical हो जाएगा. Division by 0 is not allowed. That's mathematics. Yes. Now interpretation. Logically क्या बताएं?
कोई लोग हैं ही जिनमें डिवाइड करना है, फर्स्ट टाइम टू इक्विवेलेंट डिवाइड.
वो भी division by 0 ही किया आपको बताया ना, probability आता है. You are saying that what's the probability of A given that D has happened? Yes? And now I ask you, what's the probability that D happens? You say 0, that is, D was always impossible. Yes? So then why are you telling me that D has happened if it was impossible to begin with? Yes? So interpretation shows you that the division by 0 wouldn't make sense here either. Yes? Because you start by saying probability A given that D has happened. Now when I want to calculate it, I ask you for P of D, you say 0. In probability 0 means impossible. Won't happen. Yes? If it won't happen, if it's impossible, the conditioning doesn't make any sense. So it becomes logically, internally inconsistent. Yes? This whole formulation, this discussion becomes internally inconsistent. And mathematics, above most other things, tries to be very consistent. Yes? So that makes sense. Okay. Probability of A and B is 1 by 6. Good. That is, conditional probability. We have this. Posterior, yaad hai, we did an example and we developed with that. Again, please watch the video if you don't remember. I won't have time to develop it again. But it is this way. Often we come across situations where we know the probability, unconditional probability of an event. Okay? And we want to update it once we realize or find out that another event has happened. So we want to update this. This was before any new knowledge comes in. Okay? Whatever knowledge we had about it, we got it, we gave it a probability. Now, when new knowledge about A comes in, that is some event B occurred, I want to update this. This is called prior or a priori, right? Prior probability, and this is called posterior, after the fact. Okay, once you know that B has happened. So for that, we were able to show that it is probability B given A times probability of A divided by probability of B. Okay. So where does that come from? I'll let you try to see what happens. It's actually the use of this formula once again. Okay. So essentially it helps you do this. And this thing is called Bayes' theorem. And I mentioned last time, Bayes is a well-known mathematician in the field of probability theory. There's a Bayesian statistics, whole field of Bayesian neural networks being used. So it's good to know where it all begins. It begins here. It says that you have some probabilities before events or before knowledge of events, and we want to update them. Then if in many situations we have this information. And the example I gave last time also showed why we have this information. Yeah. So just please review that. Again, up to here was revision. We also talked about independence of events. Yes. So as we saw here, probability of A given D. Yes. What happened there? The probability of A was 1 by 6. Probability of A given D became 1 by 3. So was probability of A equal to probability of A given D? Was it equal? No. It had changed. Why had it changed? Because the information provided by D mattered. Yes? Now there are situations, there is information that if provided does not change the probability. Okay? So if probability of A given D still remains probability of A, then we say that the event D, knowledge of event D does not affect the likelihood of A occurring, and we say the two are statistically independent. Okay, again we covered that in detail, so I just want to mention that here before I go to the last part here, total probability. So we up to here just what I discussed, we did it in great detail. You should review that. We come here to total probability, and we will make use of these guys actually. That's why I wanted to at least refresh just enough in your mind so I can continue. Okay, so we will start with an example. Suppose that your team is to play PSL. कौन सी वाली होनी है? नंबर क्या है? By year चलती है. PSL 23 हो तो नहीं गई? Okay, fine. 24 में, ठीक है? Right. So you are going to add a team there, and I will erase all of this. Okay. So your team is going to enter PSL, and your team is going to play against one of 3 teams. Peshawar Zalmi, yes, Quetta Gladiators, Lahore Commanders. Now your chances of winning from each, you have some calculations. Let's see. Yeah. What we want to know is what is your probability of winning a match if your opponent is chosen at random with equal probability. So let's write this down first. Okay. So I will define events. With probability problems, you always have to start by defining events. Okay. If you can define good events, then you are able to formulate the problem very well. Let's say your team is called, क्या नाम है? I have a name in mind.
Islamabad United.
वो तो फिर कोई इस्लामाबाद से होगा, कोई कहीं से होगा, right? We are in Topi. Yes, so our team will be Topi Drama.
Topi Tigers.
और Topi Drama seems more interesting. What do you say? क्योंकि हमारे साथ जो नहीं है, उसके बाद ये नाम थोड़ा justify हो जाएगा. Yeah. So let's say we have this team, Topi Drama, in the match. And we say, okay, we define an event W that our team, the Topi Drama, wins. The event W says Topi Drama wins. Yeah. Let's define another event Z that Zalmi is chosen to play with you. Okay. Similarly, there is event Q, Kalandars are chosen, and there is event, what's the last one? Gladiators are chosen. Yeah. So these are just events. I'm not assigning any probabilities so far. Okay. So we want to find the probability that drama wins. What are we given? I will read it again, so we will then write it mathematically. We say your team is to play one of these, okay, and your chances of winning from Zalmi are 0.05. Okay, can somebody help me write that in mathematics now? Probability, your chances of winning if you play Zalmi is 0.05. Okay, that's the probability, yeah. So probability of what?
Z.
W of winning if you play Zalmi. So what should be here? Given. See, the already it's starting to make sense, this knowledge. So if you play Zalmi, your chances of winning are 0.05. Your probability of winning if you play gladiators are 0.04, and your probability of winning if you play Kalandars is 0.1. So आपने दुआ किसकी करनी है फिर? One, they will be chosen at random with equal probability. Let's say in this example. So Kalandar की दुआ करनी है, right? क्यों? Because if that happens, your chances of winning are very high. I am not interested. This is given to me. What I want to find is at this point at the start, then I have this information. What's the probability of my winning? Okay. So by the way, can somebody help me write this? What's the probability that Zalmi is chosen? I have already described it in the problem statement. That is, what is your probability of winning a match if your opponent is chosen randomly with equal probability?
1 by 3.
1 by 3. And what about Q and G? All
1 by 3.
1 by 3. Yes? So they are chosen randomly with equal probability. Sometimes students confuse when we say they are chosen randomly, they think they are equal. Random doesn't mean equal probability. Some things can be chosen randomly, but some parts could have more probability than others. But in this case, random and equal probability. So then, now what's the probability W? Can anybody tell me? Problem समझ आ रहा है? Now we have bits and pieces of information, but we now want to bring it together. इस वक्त आपकी टीम के जीतने के chances क्या हैं? We know the team hasn't been chosen. After one is chosen, you already know the answer, right? If Zalmi is chosen, this is the probability. You know that. Before they are chosen, and you know only how they will be chosen with equal probability. Yes, randomly with equal probability. So then, what's your probability of winning?
तीनों को ऐड करेंगे डिवाइड बाय 3 कर दें.
इन तीनों को ऐड करेंगे.
डिवाइड बाय 3 कर दें टोटल.
अच्छा. No, that would be wrong. But we will see. और कुछ?
So ये फॉर्मूला probability है ये
कौन सा है बताएं जस्ट.
सर
What would be A? What would be B?
A तो हमारे पास अवेलेबल है ना W given G. वो उसको ले लेंगे हम कि B given A की तरफ है particular probability of Z probability of choose किया.
Yes. Okay. So I will write it. I need space here. So ये याद नहीं करना आपको तो simple है क्या लिखा है यहाँ. So I will erase this. Sometimes इसका नहीं होता है.
इसको साइज इंक्रीज कर दें. सिलेक्ट करके
पॉइंट है ना.
एरिया वाला से कर लेंगे. पूरे को सिलेक्ट करके ना वो पूरा मिल जाएगा.
Okay, thank you. So I'll first describe it. Okay. How can you write mathematically your chances of winning? If I say this, you win if. By the way, what can you say about they are equally likely or not? These three. Yeah. Are they mutually exclusive? In this example, that Zalmi is chosen, gladiators are chosen, Kalandars are chosen. It's mutually exclusive. One of them has to be chosen to play, right? So they are also mutually exclusive. Good. So equally likely, that's mutual information, but they are mutually exclusive. That's good. So what if I say, okay, you win if you play Z, and what happens? Win. That's one way you will win. Yes? What's another way? Or you play calendars and win. Agreed? Or you play gladiators and win. These are the only three ways you can win. Or the win. Yes? You have to, it has to be among these. Are these three mutually exclusive? They are. So they are mutually exclusive. Okay. Then can I write these mathematically? कोई बता सकता है इस ये क्या बनेगा? You play Z and win. Probability Z. Is it given or and? Joint है या conditional? इस केस में तो it is joint. Given is here. Yeah, I'm not saying you play Z, you win given that you are playing Z, right? Both are uncertain at this point. Yes. The way you win is these are two events that haven't happened yet. We're not assuming any knowledge, right? That they have happened. So it is probability Z and W. Yes. So this is probability W equals either this happens or, now since they are mutually exclusive, I can just sum them. Yes. So the or simply becomes a summation. When they are not mutually exclusive, it's not a simple summation. There is another term. Yes, but now I don't need it. So probability what? This one, Q and W. Probability of winning is that you play Zalme and win, or you play Qalandars and win, or you play Gladiators and win. And since they are mutually exclusive, I don't need to do that. Yeah. But I don't have these. Do I have these in this problem at this point? No. Yeah. You could say, okay, let's try to find that. But I'll tell you, you don't need that. Whatever information you have will work. So, क्या करेंगे अभी? Well, we have a formula, right? Probability A given B क्या होता है? A and B divided by probability of B given that probability B is not 0. Yeah. So इस पे apply कर दें. Yeah. How? Bring this here, and then you have the right hand side, which is this. Agreed? So what does this look like in a conditional probability? Probability Z given W, or is it W given Z? Because we want to write W. So I will change that. This problem that won't help us. So we want probability of winning given Z, because we have that, times what? Probability of Z. Yes, I'm just applying this formula by shifting this here. That's all. Yeah. Plus probability win given you play Qalandars times probability you play Qalandars, plus probability of winning given that you play Gladiators times probability that you play Gladiators. Yes. Now can you find your probability of winning, your chances of winning before your opponent has been chosen? Now you can find it. Yes. So you have this. Yes. You have this. Yes. You have all of these actually. So you can find the probability of winning. Now this way of calculating probabilities from a collection of conditional probabilities is called total probability. Okay. This approach has a name. It's called total probability. And it has a general formulation. Here I developed it from just for this particular case, but it has a general formulation. I will write that now so that we have that. with us. Let's use our eraser. The area is okay. So it's like this. First I will write the formula, then I will explain it. You have already seen the formula. Probability of an event B equals summation probability B given A k times probability A k. Okay, for all k in that problem. Okay. Now, what are AK in this case? If you read this formula, summation, it's just these three terms.
AK for teams.
Yes, AKs are the team. Yes, and what's B in our case? The winning. Now, for this formula to work, it's a very general formula. It doesn't just apply here. The only thing you need is this. Firstly, the AKs must be mutually exclusive. Okay, otherwise this formula fails. Okay, so AKs are what? Mutually exclusive. Yeah, what is that? Probability of A1 and A2 occurring at the same time is 0. This case में थे mutually exclusive? Yes. You couldn't pick Zalmi and Gladiators. Yes. So it was mutually exclusive. That's one condition. Second condition is that they should span the universal or the sample space, the universal set. Also, the union of AKs, overall K, this is big U, yeah. Union of all A's should be the total sample space. There shouldn't be any other possibility. In this case, probability you had to play either Zalme or Gladiator or चौथी team तो हमें नहीं describe की. That was the only possibility. So together those three were mutually exclusive, and together they form the total set of possibilities. Now, whenever these two conditions are met for any set of AKs, okay, you can find the probability of an event, a total probability of an event from a sum of several conditional probabilities. Okay, and this is the total probability formula. Okay, there it was a specific case, and here we are looking at it in general. Any questions here? Of course, you will have to go through this example again. Yes, थोड़ा सा उसको आप relate करेंगे. But I don't want to show you the formula directly. We came to that, we arrived at that formula, and now I'm telling you that whatever we arrived at is actually very general. It has a name, it is well known, it's a very powerful tool. So again, back to what we were covering: joint probability, conditional probability, third one, posterior, and now total. Okay, so of course there are many more things to discuss, but at this point I wanted to cover this thing only. Now, going back to something that we have been doing before we go to the second module of this course. Remember, I mentioned the first section. The first module was assigning probabilities. So far we've been talking about them. Yeah? The second module is collecting probabilities in an efficient way. So I'll come to that. But before that, in the process of assigning probabilities, there is something that will help you, and I want to cover that. If you remember, for the case of dice and all those others, 3, 4, 5, 6, let's say what's the probability of 2 or 4 showing on a die? Yes, it's 2 by 6 if they are equally likely events. Yeah. So I had mentioned that this will be if you remember, I said the probability of A in such situations would be size of event A divided by size of the total sample space. Yes? Now size basically sets means just to count the elements. Yes? So you have to count A and count S. Now in this kind of situation it's very easy, you can just see. Yeah? But it's not always that easy. Let's say you have a combination lock on a door or a briefcase. Combination lock for the digital. Yeah? So what's the probability that the combination log, the combination chosen by a particular person starts with a 1? Yeah? Now suddenly काफी सारी आपको क्या करनी पड़ेगी, combinations, permutations. Yeah? So often when we are dealing with this issue, we have to deal with the issue of efficiently or finding a quick way of counting the number of elements in a set or the number of possibilities in there. So that's the part I will cover now within the first module, and then we will come back to this thing, and that we describe as, of course, counting. Yeah, not accounting. So that's different. So as I said, you will need that. So let's see if I have this. Yeah, as I said, easy cases, yes, very easy to count in many cases. But then it can really become hard. For a 3-digit combination log, what's the probability? Combination starts with 1. Okay, so the tools we are going to use will rely or depend on these two questions. Okay, whenever you have to count the number of possibilities or the ways things can happen, you have to ask yourself two questions. किसी को पता है? Yeah. Counting पे आपने formula किए हुए पहले, I'm sure. Yes, in college. Right. The two questions you have to ask yourself are: does the order matter? Okay. So in this combination log example I gave, what's the probability that the combination starts with 1? Yeah? Does order matter here? It does. Yes? 1 has to be at the start. Yeah? Let's say there is someone's combination is 3 to 1. Does that satisfy my requirement? I said combinations that start with 1. So order matters. I'm not saying we have to answer that now, but it is the general question you have to ask. Does order matter? Second question, कोई guess कर? बहुत common is repetition or replacement allowed or not? Okay. In this example, are repetitions allowed? Combination log में
Yes, sir.
हो सकता है पहला भी वन दूसरा भी वन तीसरा भी वन doesn't matter, yeah? So repetitions are allowed, but these are the two general questions, and I will talk to you about this example. So once you cover this, you will get a feeling for what kind of counting we have. This was written for a course I gave in Saudi Arabia, Riyadh, which I didn't change because if I had written rupee, the exchange rate would be changing. So let's stick to this, yeah? Okay. Let's play a game. There are 3 people, Ali, Bakr and Zaid, and you choose 2 of these, and I will give 10 riyals to each. Cannot choose same person twice. That's the game. ठीक है? समझ आ गई game? You have to choose 2 of these. I will give them 10 riyals each. You cannot choose the same. So what's the 2 questions to ask? Does order matter? Is repetition allowed? So what's the answer to the first question? No. Why? दोनों को 10 ही मिलेंगे जो भी order हो. Yeah? Okay, fine. What is the second? Is repetition allowed? No. Yeah? So how many ways can we choose then? कितने आंसर बनेंगे? 6 बने? How many ways can you choose for this game?
Just one.
Just one? Yes. One of you chooses Ali Zaid. That's one choice. Another one from you chooses Ali.
Ali repeat हो जाएगा sir. You cannot choose the same person.
No. एक बंदे ने तो 2 ही choose करने, but you cannot do Ali. That's what it means, repetition. Yeah? मतलब अभी मैं आपसे कोई में से 2 बंदे choose करें, repetition नहीं करनी. ठीक है, और मैं कह रहा हूँ ऑर्डर डजंट मैटर बिकॉज दे विल बोथ गेट 10 रुपीज। अभी आप में से एक कोई बोलेगा वो चूज इनको करेगा, कोई और बोलेगा वो इन लोगों को चूज करेगा, राइट? दैट्स व्हाट वी आर टॉकिंग अबाउट। अनदर वन मे चूज बकर एंड ज़ैद, एनी अदर वे? Someone may choose Zaid and Bakr, but in this case won't matter. Yes, क्योंकि दोनों को 10 वैल्यू मिलने, doesn't matter. So there are, or it doesn't matter repetition or log. There are three ways. Yes, yeah, you could say if one chose Bakr Zaid, the other said yeah, but I want to choose other Zaid and Bakr. Doesn't matter. इस game में कोई फर्क नहीं पड़ेगा उससे. Yes, so three ways. Okay, let's change it. Make it interesting. Choose two of these. I will give you 10 riyals. I will give 10 riyals to the first one and 5 riyals to the second one. You cannot choose the same person twice. Yes? So, आप कितने हो गए? पहले वो questions.
Yes.
Does order matter?
Yes.
Yes. क्यों? पैसों का मामला है. अब पहले को ज़्यादा मिल रहे हैं, आप पहले खड़े होकर कुछ करेंगे लाइन में. For you. Yeah. So now all of a sudden, Bakr Zaid and Zaid Bakr is not the same thing, is it? It has become very different now. पूरे 5 हजार का फर्क पड़ा है. Right? ये मुझे millions में लिखना चाहिए था, ये तो जो थोड़े नहीं है. Anyway, what about repetition allowed? In this case, I have written there, it's not allowed. Yeah. So कितने तरीके? How many ways can you choose now? 6. Yes. वो पिछले 3 और फिर हर एक में.
पहले तीनों को 10 रियाल मिलेंगे, फिर तीनों को 5 रियाल मिलेंगे.
हर जो दो चूज करेंगे ना, उससे पहले को 10 मिलेंगे, दूसरे को 5. Yes. So now it is 6. You could choose Ali, Bakr, so 10 and 5, or Bakr and Ali. In the previous example, they were the same thing. That didn't matter. 80 मिले थे. अभी this is very different. Here Ali gets 10 and Bakr gets 5. Here Bakr gets 10 and Ali gets 5. So there are 6 ways you can choose. Yes, they will have different consequences. Okay, let's make it even more interesting. I give 10 riyals to the first one, 5 to the second. You are allowed to choose the same person twice. Okay, अब क्या हो गया? अभी एक बंदे को 15 रियाल भी मिल सकते हैं, right? कैसे मिलेंगे? दो दफा choose कर ले. I allowed it, yeah. So what is, does order matter? Yes or no? Yes.
Yes.
Is repetition allowed?
Yes.
Yes. So you are allowed to choose the same person twice. आप कितने हो गए? 9 हो गए. Yes. So ये diagonal, ये this one. Before previous one में ये नहीं था, right? It wasn't allowed, so अभी add हो गया. Because you could choose this. Here Ali goes away with 15 riyals. Here Bakr goes away with 10, Ali goes away with 5. Here Ali goes away with 10 and Bakr goes away with 5, and so on. So essentially, this is just to show you the example. Good point to note is that most number of possibilities when order matters and repetition is allowed. Possibilities बढ़ती जा रही हैं, right? 9 होगी, 3, 6, 9. Yeah. Okay. So here is the summary. असल कौन है ये चीज? Of course, you won't do any that's just crazy, yeah. So you know these formulas of permutation and combination, but how do you choose them? This is the legend here. This is the key. Total objects and those could be digits you can choose from. Yes, those could be, as I said, people. Those could be positions where they are placed. Very different things. But in the end, is total number of choices that total pool that you can choose from. In our case, n is 3. बंदे तो 3 ही है ना in all 3 examples. Yes. So objects to choose or number of places to fill. कितने choose करने थे हर example में आप लोगों में से? 2 choose करने थे. With different answers to the question, does order matter? Is repetition on? But in each case, there were 3 people. And you had to choose 2. The only thing that changed the answer was the answer to the 2 questions that I mentioned. Yeah, otherwise N and R are the same. So if order matters, and repetition is allowed, you use power. Okay, वो जो आपका 9 आया ना, that's 3 square. Yes. Okay. If order matters, repetition not allowed, you will use permutations. Okay. And if order does not matter, repetition not allowed, you use combinations. Okay. So ये आपको I think पहले combination permutation so already done. Combination is where order does not matter. याद है वो पढ़ा होगा. Then there is the power formula also. You know 5 factorial whatever. So for our example, in each case, as I said, n is 3, r is 2. But depending on the answers, you will either use this was the third case. Yes, this was the second case. Permutations were allowed. Order was mattering there, but repetition wasn't allowed. Yeah, and then the first case that led to 3. If you apply this formula, you will still come up with the same answers. Okay, so of course you have to practice this, try to understand the situation you're dealing with, and once you have identified, but it becomes very easy. You should know this, that what you're dealing with, answer your 2 questions, does order matter, is repetition allowed. Once you have answered those, mostly it becomes very easy. Of course, you also have to answer what is n, what is r. You have to establish that from the start. Yeah. So, yeah, we'll do that later. Any questions so far? Clear, Sarah? At least no immediate questions. That's good. So, this now allows us to go to the second module of the course. What was the first module? Assigning probabilities. ये हमने क्यों किया? It helps us assign probability also. Yeah. Now the second module is collecting probability. Yeah. So you do that with the non-probabilistic mathematics already. Yes. Let's say there are points on a line. Yeah. So the points on a line, you collect them in a formula, don't you? What's the formula? Y is mx plus c. So you have collected that in a very nice way. Now the parameters are m and c. Yes, you have a parabola. Then you have already collected that in a formula. So probabilities also need to be collected somehow. So the next thing or the next module is all about collecting those probabilities. And I have to find my slides. Yeah, so that we've done. As I said, assign those. We will see, okay. But before that, there is something we need to do, and it's here. We have talked about random events. Yes, event that you win, event that what's the height of the next student coming in. Now what we want to do is to go from random events to random variables. Okay, bring in some proper mathematics now. So then we will see how to collect those probabilities. Okay, let's see how we go from random event to random variable. Let's see the next student who enters the room. Firstly, he or she would be extremely late. Yeah. Other than that, what's going on? Let's say we want to talk about number of mobiles he or she has. Next one होगा. आपको अपना तो पता है कितने आपके हैं? Yeah, let's कोई चुपके से जेब में डाल दिया. Lucky. Yeah. So number of mobiles the next student has, height of the next student that comes in, or Z, is he or she from this Swabi region or not? What are the possible values of X, Y, and Z? Yeah.
Possible value.
X की क्या possible है?
1.
Yes. -1 नहीं हो सकता. नहीं हो सकता. क्या है?
1, 2, 3, 4.
Yes. So इसके होते हैं natural numbers 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So unless you want to count a broken mobile as half, let's not do that. So या एक होगा, दो होंगे, तीन हो गया, जीरो होगा, माइनस नहीं हो सकता, 1.3 नहीं हो सकता. Yes, okay. What about height? Continuous है. Yes. Depending on how well you can measure, नैनो स्केल तक भी जा सकते हैं. It's basically continuous. फिर आप खुद उसको रोक लेंगे depending on what instrument है, but it is continuous. What about Z? Is there from strawberry? Yes or no? Not a number. Yes. This doesn't have an answer. It is a number. So the possible values, as you said, also x has discrete set of values, y has continuous set of values. What is the difference between discrete and continuous?
We can count discrete and whole numbers of the continuous के अंदर भी जो points हैं
uncountably infinite होते हैं वो, और साथ whenever there is a range, and within that range any number is, any value is allowed. Yes, any value can be taken, then that part becomes continuous, right? So in this case, of course, x is discrete, y is continuous, and z is just a description. It has no numeric value. Why am I talking about that? Are x, y, and z random events? Yes, they are. Yes, that was the number of mobile the next student has. I'm not sure how many. Yes, the height of the next student, I'm not sure. They are all random events. Yeah, is he or she from Swabi region? I don't know. There is uncertainty there. Yeah, so all are random events. But are they all random variables? No. The first one is a discrete random value. Okay, why is that? X takes on a value based on a random event. Yes, that's one thing. The value it can take is discrete. So it's a random variable which is discrete. Y also takes its value based on a random happening. Next person coming in is a random occurrence. Yeah. So it's a random variable but continuous. It can take continuous values. The last one is not a random variable, it's just a random event. To qualify for being a variable, to work with numbers, we want to work with numbers, yes? So in probability theory we say that if it's just descriptive, it's still a random event, right? But it's not a random variable. So then how do we define a random variable? Well, I just did, but I'll just summarize it. It's a variable whose value depends on the result of a random occurrence. Okay, that's important. Always takes numeric values. So x and y satisfy that condition. Can be continuous or discrete. As we saw, x was discrete, y was continuous. Then there's some additional conditions. I won't go into those, but one of them is that probability x equal to infinity is 0. That is the probability that takes value infinity should be 0, of course 0 it is. But it's a bit early for you guys to start worrying about that. Focus on the first three first. Now we can convert a random event into a random variable by assigning it numeric values. For example, this person, Joe region, we could just imagine Swabi region, that's fine. We said yes or no. It wasn't a random value. But I could map it. A yes, I could say 1, and a no is 0. And this thing, the value taken by z based on that mapping and the random events becomes a random variable. Is it discrete or continuous? Discrete. And it is binary. Further, it can only take two values. Okay? The mapping is not unique. You could say not from Surabi region -1. It's up to you. Okay. When events don't have when they have just descriptive values, and you want to convert them to random variables, the mapping is non-unique. You decide based on the problem setup. But all I want to show you here is that you can do that. So then with this mapping, now z becomes a random variable. We are saying z is 1. If next to the entry room is from a particular region, it is 0. if not from that. Yeah. So that's just to take away the question. Okay, what happens to descriptive events? You can still work with them mathematically. Okay. So we discussed that already. Repeating. Okay. Collecting probabilities. Right. So here, now we want to really talk about how do we represent probabilities of different values of x and y. Let's see. X data, number of mobiles the next student coming in has. Yes? So, किस तरह represent कर सकते हैं? What comes to mind? One way is to make a table. Okay. Remember, we're not assigning probabilities now. I'm not saying why is this point one. वो हम पीछे discuss किया और we will come back to that again. Based on collection of data, you can decide what's the likelihood of people having one mobile. Now you can guess easily, yeah. One is the highest likelihood, obviously, yes. फिर zero कम हो जाएगी, उससे अलग भी कम हो जाएगी. Anyway, what I'm saying is once you have the probabilities, how do you collect them in an efficient way? Well, you could make a table, or you could have a graph, heights of people we know. Yes? I'm not saying it will be this graph always. All I'm saying is the mode, the way you collect this information. The likelihood of certain median heights is very high. Very short people, very unlikely. Very tall people, very unlikely. Yes? So you could have different kinds of graphs. Or, best yet, you could have formula like for the deterministic case of a line y equals mx plus c. Yes? You collected, now if you give me m and c, you know what you have done? You have collected all the points of that particular line in one formula. You just gave me two parameters, and now I can find any point of that line, can't I? Again, yeah? So, we're not going to where we got this from, we'll come back to that later. But rolling a die, we could collect this probability as a function. What's the function saying? It's saying that the probability that z takes the value 1, that is the die shows 1, is how much? 1 by 6. The probability that it takes a value 2 is also 1 by 6 because there is no change here. It's just saying for any of these it's 1 by 6. Yes? इसका ग्राफ ड्रॉ करेंगे तो सीधी लाइन ऐसे 1 by 6, yeah? Then it could be some bell-shaped curve as you saw. So graphs are possible, and that is actually the mathematical functions, and then we draw the graphs, but basically it's the mathematical functions that we use to collect probabilities. Okay, so just like for parabola, for line, for hyperbola, for many other geometric shapes, or for other kind of deterministic behaviors, you have formulas. Similarly here, we will have formulas for these. So we will focus on discrete random variables first. याद है क्या होता है discrete random variable? I just described it. Let's say random variable is a variable that takes value depending on a random event. Yes, and the values we can take are discrete. That's important. Yeah. So first we focus on this thing. The formula shows. So what I want to mention here is, let's see if I can go to, in collecting probabilities, we will have 5 kinds of functions. Okay, there are more, but this is where these are the pillars of this whole module. The 5 kinds of functions that help us collect probabilities in different kinds of ways are these. The probability mass function, sometimes called probability distribution function. Okay. Second, the y equal to mx plus c is a function. Yeah, it's a formula that relates on. So there is this. There is cumulative distribution function. Cumulative. CDF. There is joint probability distribution function. Joint. Okay. And then there is marginal distribution. And then finally there is conditional distribution function. You could also write the function is fine. Of course, you don't have to memorize these now. I'm just giving you an idea or a map of what we plan to do next. Yeah? These are the 5 concepts in the way, or the functions in the way we collect probability. If you understand them really well, and the second module is mostly done, and you basically then are ready. Yeah, I didn't see here, sorry. So let's do this conditional distribution function, okay, or conditional distribution. So of course we will do all of these in detail in the lectures also. So let's go back to where we were, to the very first one. Okay, when we collect probability in a simple function for a discrete random variable, we call it probability mass function. It also has a name, probability distribution function. When we go to a continuous random variable later, you will see we will call it probability density function. Why distribution and density? That remains to be discussed when we go to continuous case. So what is it saying? It's very simple. It's saying fx is going to, from now on, fx is going to represent what? Probability that the random variable x takes the value small x. Okay? Is there any confusion? Let's say x is the number that shows x, capital X is the number that shows when I roll a die. Okay? So what are the possible values of small x now? 1, 2, 3, 4, 5, 6. If I say probability x equals 3, I'm talking about what's the probability that a 3 shows. How will I write that here? F3. Yes? So that's a compact way of representation. It's just a representation. But it will come out very handy. He is saying, so from now on you should be able to read this. For a discrete random variable, the probability mass function f of 3 means probability that the random variable x takes value 3. In some texts we write capital X here to emphasize that, but we can skip for now. Okay. What are the conditions fx must satisfy? We discussed 3 conditions that assigned probabilities must satisfy. Are they 2 axioms? Probability cannot be negative, and so on. So what do you think are the 3 conditions this function should satisfy? This one. Any one you can think of? Can fx, for any value of x, can it be negative? No. Why? Because the right hand side already satisfies this condition. It has to be between 0 and 1. Yes? So that will immediately copy here. Yes? Okay. So that's one condition. Always greater or equal to 0, cannot be negative. The total sum should be 1. Just as we saw that the probability of the sample space had to be 1. Similarly here, when you add all the possibilities, they should sum up to 1. Okay, that's one. Third thing. Lastly, it is just saying that it should be a representative of the probability. It should represent a problem. So these are the 3 conditions that the probability, and they are directly copied from what we did in the, I think it was the second lecture, where we discussed the axioms of probability, the rules that probability must follow to make sense. Okay, so from there it directly follows. Any questions about this?
ये जो थर्ड वाला है, ये किस तरह ये समझ नहीं आ रही, मतलब कैपिटल X इक्वल टू X आई, इससे क्या मतलब है probability?
all it's saying is that the function fxi must represent the probability as definition जो मैंने यहाँ बताई है, this one. Yeah. So, for example, as I said, rolling a die. Yes. Now the result, the number that shows, we will call that result or the event as x. Yes. What are the values of xi in that case?
Even number.
No, I'm saying numbers that show up once you roll a die. Yes, any number. Yes, 1, 2, 3, 4, 5, 6. So it is saying f of 3 would mean probability x equals 3, okay? And so on. And of course, together the probabilities should sum to 1. या 1 आएगा या 2 आएगा या 3 आएगा 4 आएगा 5 in rolling a die example. Yes. So the probability mass function has to satisfy these conditions. So let's play a game. Let's say you have a bag. There are 3 balls in it. One and written 1, 2, 3 on them. You draw one ball at random. Yeah. X is number written on the ball. Is it a random variable?
No.
Is X a random variable?
Just a random variable. That's a random.
वो तो बाद में देखते हैं. पहले is it a random variable?
Yes.
Is X a variable? Yes. Yeah. Does it take its value based on a random event? Yes. So it is a random variable. Then the value is discrete, is numeric. Yes. So is that discrete or continuous? Yes. Discrete. What are the values it can take? Now those will go in the small x here. Yeah. What values can it take? 1, 2, or 3. Then fx equals probability x equals x. If you want to tabulate it, this is how it should look. What's the probability that x takes the value 1? That is, the ball you draw has a 1 written on it is 1 by 3. What's the probability of the other one? There are 2 written on it, 1 by 3 and so on. Does this fx satisfy the conditions? It's always less than 1. The sum is 1. Yes, and in each case it represents the probability. So the 3 conditions are met. You could write that mathematically. How can you write it mathematically? This thing. You can say fx equals 1 by 3 for x equals 1, 2, 3. Constant का आपने एक formula define कर दिया. Yes. So now the second one, cumulative distribution function. Often we want to talk about range of values. Okay, so for example, here we might be testing, okay, what's the probability that the student entering the room has more than 2 mobiles? Yes, we often talk about range of value. What's the probability that at medical center 50 people show up at the same time? More than 50 people show up, let's say. Yeah, if you say 50 people show up, you are talking about one distribution function. But if you say more than 50, which is your breaking point, then you want to have ranges. Here we are talking about probability of one value. Yeah. Here we are talking about a range. Probability x is, we are not saying equal to 2. That would be covered by probability mass function. We are saying probability the student has more than 2 mobiles. What's the probability that a student has 2 mobiles or less? That's very high, yeah? But you know, like that. So for such situations, we have cumulative distribution function. Here it is. What does it say? Now the f is capital here. Okay. So what does it say? Probability x is less or equal to x. Can you write this new function in terms of the small fx? Try कर सकते हैं हम?
Equal होंगे तो किस तरह कर सकते हैं?
Here it is. Okay. So I want to write fx, the capital Fx, in terms of small fx. इक्वल तो नहीं है, यस, सो क्या होगा, summation, yeah, why? So let's say what's the if I want to see what's the I roll a die, yes, now what's the probability that it shows a 1 by 6, probability it shows a 2 1 by 6, so on. What's the probability that it shows 3 or less? You will add the probability that it shows 1, probability that it shows 2, probability that it shows 3. You will sum the 3, won't you? So you will go up to this point, right? So summation here, and we could, for our convenience, put an xi here, and we say okay, x. In fact, we don't need an I here, so we will do xi less or equal to x. That is, ignore this, yeah. So in that case, what's the probability that the number shown on the die is 3 or less? Is the summation of probabilities of the values before that, up to that point, yeah. So yeah, this is it, okay, and I'll show you here, okay. This is the die rolling example. The probability of each number showing is 1 by 6, okay, but what's the probability? By the way, how would fx look here if I wanted to draw it? So what would be f1, capital F1? Can anyone tell me? Small f1, yeah, up to that, so it's 1 by 6. What is capital F2? Probability that a number less or equal to 2 shows up. What's the probability?
1 by 6 plus
1 by 6 plus 1. So what you did was you added small f1. This is f1. Okay. This is f1, small f1. This is small f2, small f3, and so on. Capital F2 is the sum of all these up to here. Yes, that's what the formula was saying. So basically it will look something like this. Agreed? Because you keep on adding new values. Yes. So what is the probability that the number showing is 4 or less? How much is that? You can see it will be 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. Yes? Because probability of 1 showing, 2 showing, 3 showing, 4 showing. Yes? So again notice it here. This point represents capital F3. And the number showing is 3 or less. Remember the definition, what was it? It is probability the number showing is less or equal to 3. Yeah? So the edge of the board. Okay? So cumulative just adds all the previous up to that point. It adds all the probabilities. Okay? So let's see here. Yeah, 3 conditions it must satisfy. Again. Yeah, right before, because it also inherits from the differential probability. It has to be between 0 and 1. It has to represent this one. This thing is new. What is that saying? Last one. If x is less or equal to y, fx should be less or equal to fy. Okay? What does that mean? This is here. CDF has to be a non-decreasing function. Okay? So it cannot go down. Why can't it go down? So let's see here. For the die rolling example, yeah, what does F3 represent? Capital F3. probability that 1 shows, 2 shows, or 3 shows. Yes? That is, it's actually adding small f1 plus small f2 plus small f3. Now, what would f4 mean?
0.
Capital F4. Yes? So, it would mean 1, 2, 3 or 4 shows. So, mathematically it will have to be f1 plus f2 plus f3 plus f4. Yes? Now, here what is x? 3. What is y? 4. That's it. Is x less than y? Yes. Then f4 cannot be less than f3. Why? क्यों नहीं हो सकता?
f4 की भी probability
ऐड होनी है वो तो होगी, लेकिन आप नेगेटिव नंबर्स भी तो ऐड करते हैं ना चीज़ों में. यहाँ क्या मसला है? Probability cannot be negative. So you will either add a 0 or a positive number. Yes? So there is no way this can go down. Yes? So if you plot and say this is f here, capital F, and this is small x, this is 3, and this is at 4. Wherever you were at 3, yes? You either at 4 you either go up because you add a positive number, or you stay there because you add a 0 number, 0. But since probability cannot be negative, you will never add, this value will never be negative. So there is no chance that you will go down. And that's what you saw in there also, right? It wasn't, let's see here, see, it could at some points remain constant. That's fine because probability can be 0. So the new term you add may be 0, but it cannot be negative. So that is the cumulative distribution function. Basically it's saying it is strictly non-decreasing. Let's write that. कोई याद करेगा जल्दी से जरा. Example याद है, there is a bag, there are 3 balls in it, written 1, 2, 3, you take out 1 ball. Yes? So we have already calculated the probability. This is small f. Yeah, what was that? Probability mass function. Yes? What did we find it to be? That the probability that x takes the value 1 was 1 by 3. Probability that it takes the value 2, 1 by 3. Now I want this one. Yeah? So I want to find basically.
So 1 by 3 होगा 2 by 3.
Yes, exactly. I want to find f1, f2 and f3, the capital F. So what's the value here?
1 by 3.
1 by 3. Why is that?
Because 1.
Just because you know that it has to be f1. Why? Because there are only 3, small x has only 3 values, right? 1, 2 or 3. So f1. What about f2?
f1 plus f2.
f1 plus f2. Good. And f3?
f1.
f1 plus f2 plus f3. Okay, good. So if you do that,
2 by 3 and 3 by 3.
that is 1. Yeah, in the end, 3 by 3 is 1.
Yes.
So eventually cumulative always ends up in 1 and then it stops. उससे ऊपर तो नहीं जा सकती. Yeah. So yes, that's it. Yeah. That is the cumulative, and you can check that it satisfies all the conditions we have already discussed. Then you can use it to find many different kinds of probabilities. I won't go into that in detail. You can see that later, or when you use it. Basically, together the cumulative can help you find many different kinds of probabilities. Okay? Probability x is between a and b, but not including a is one thing. Probability x is greater than a. Just you will try these out in the formulas. You will see that they all make sense, and you can test those relations over here. I will just mention a little bit about joint, and then we will come back to it next time. Okay? So, what have we discussed so far? Probability, mass function. Mass function, what was it doing? Simply for rolling a die, for example, it says, well, give me a random variable x, that is the number that shows when you roll a die. And then it has small x values, whatever possible values it has. Remember, this was we were writing in the universal set. Remember? So it says, okay, then I will give you f of any small x. I will store that for you. Yes? In this case, it was 1 by 6 for each case. Fx says, I will give you the probability, this says I will give you the probability that x takes the value small x. Capital Fx says, which is cumulative, it says I will give you the probability that x takes a value less or equal to x up to that point. Yes? And we saw that it results in a summation of these guys, which is the secondary thing. The joint probability is just like a joint probability distribution is just like the joint probability. Kitina mein joint probability of A and B. Yes. So, sorry. हाँ ठीक है ये इसका डाल दूँ आपको अच्छा let's see. Close the pen. Yeah. We are interested in seeing, okay, two things happening at the same time. What is the probability that the next student entering the room has 2 mobiles and no pen? Right, so we have a new variable now, y, which, or let's say some z or here y, that is x is number of mobiles he has, y is number of pens he has. Now you want to see x and y, which was the joint probability. But if you want to collect it in a joint probability function, then this is what it looks like. And next time we will start from here and we will discuss this guy, and it will naturally lead us to the marginal and the conditional. Okay, so remember the 5, yeah, so we will come back to these remaining 3 next time. Any questions so far, you can ask me now or later. That's it, we are done for the day.